Welcome back, guys. Today we have a solder station. This is a 90-watt station sent to me for a review, and we're going to give it a go. All you long-time viewers know that I stick with what works, and I'm still running my Unger from 20 plus years ago in my cheapo FT-80W hot air rework and solder station. Basically, it's a pretty generic unit, and I've had great luck, but thought, well, it's time to try out some other things, and this was sent to me to give it a go. So this is the TOAUTO DS90. I'll put the link on Amazon down below. Comes with pretty decent instruction. Actually, it's good English. Huh, interesting. I always kind of enjoy it when I get a decent instruction that has been translated properly. This is definitely pretty good. Hopefully it's pretty straightforward. Error codes, no part numbers for replacement parts, but these I think are going to be pretty... Oh, here we go. There's the tips, part numbers for those, how to clean it, and some contact info. Pretty cool. Should be pretty straightforward. It's packaged really well. Seems like no issues there. It is quite light. I'm surprised at how light it is. The weight is quite... Oh, cool. I'm already happy with this. Check this out. Not that I don't have a lot of tweezers already, but I love these bent nose tweezers. In fact, here's two pair on my bench at all times. I use them every day I'm at the bench, so that's a nice touch. I like that. That was not what I expected. I expected this just to be an iron and nothing more. I certainly didn't expect a solder sucker. This is just the El Cheapo plastic style. Like, I already have one of floating around the bench here that I've broken in the past. They work fine. There's nothing wrong with them. This one, yeah, this one feels good. But that's not why we're here. What do we got? Single, what is this, a ground? Must be. Oh yeah, cool, with banana jack. Interesting. For ESD safe TOAUTO soldering station. This is a slick looking little unit. This looks sharp. So, ooh, that's alarming. No replacement tip, like the entire soldering iron. Normally you would have a connector like so that makes it easy to replace these, because these do fail, especially when you run them hot like I do. They fail here, but maybe it won't fail. This is a really good feeling unit. Good silicone wire. Nice tip setup, standard tip setup. So if we go ahead and take that off, we should be into the ceramic heating element underneath. Yep, standard stuff. These do break and crack as well, where you have to change the handle, and I'm a little concerned that you have to take it apart to hack one in if you want to change it. So rotary encoder style knob, no detents, nice and smooth though. What looks like possibly an OLED screen. Interesting. So we got a roll of solder and the little solder caddy thing that I never use. I learned old school and I just hold the solder in my hand and feed it. But if you wanted one of these to act as a spool like on your 3D printer, well, there you go. We've got multiple different tips. I'm going to switch lenses here. This episode brought to you in part by PCBWay. Check them out at the link below for your next electronics project. They offer competitive rates for all PCBs, parts, and assembly, as well as 24/7 tracking of your order from start to finish. Okay, and here is our tips. This comes with the super pointy one installed, which I can't seem to focus on. And that is not the one I generally use, but here's the other ones that come with it, basically the standard assortment. We'll switch over to one of these wedge styles at some point, but for testing we'll just use the one that it came with. nifty little insert here, which appears to be the insert for here to hold our iron in place. And this is kindergarten stuff that Eric won't be able to figure out because, well, that's me. There we go. And there we go. Good fit. Off camera. It fits in just like so. Cool. No contact with anything. Comes with standard sponge, but also with our brass, what do you call that? Sponge as well. It's basically like steel wool, but brass. That's my preferred method of tip cleaning. I have one of these Hako versions that I've been using. I bought this one from Adafruit. It works great. You just pop it apart and clean it out periodically. And that's my favorite style, but this gives you both, which is pretty cool. Power switch on the top, and it's super light. There's no transformer, no switch, like there's not much in here. Really, really light. Like my Unger over there and my whip are 5 times the weight of this. In fact, do I have a scale in here? I do. Let's measure it. Not the weight of a station is really a criteria for a review, but it will give you a sense of what's in there without even taking it apart yet. So 571 grams, that's including the power cord. And let's say we bring my Unger over and see, this is without power cord because I'm not going to unstring the power cord across the bench. In fact, we get, so 1,400 grams, so a little less than 3 times. I was a little off on my 5 times, but you get the idea. Significant difference in heft. Not that that's a criteria, but there you go. Now you can get an idea. If you like electronics parts and components, well, stop by my store at store.makeme.org, linked in the description below. There you can pick up one of my custom kits or links to all sorts of Amazon products and electronics and other. Make sure you stop by our Discord, also linked below. There you can meet with other electronics enthusiasts and hobbyists and keep track of all the projects, updates, and videos. Alrighty, let's give this thing a go. I noticed one thing right away. Check this out. We have, everything's fine as long as that goes down in there straight and true. But if it's at all sitting in the cradle incorrectly, the iron is hitting the back here. That is probably going to be a problem. Let me see if I can get it so you can see it here. Yeah, see? There. That is, that's an oversight. I can see being a problem unless this is some kind of high temp plastic, so let's give it a go. Okay, we're plugged in, power on. I like the display. That's kind of cool. A little dual color action. So we'll go ahead and go to the limit. So we've got normal metric for all of us metric folk, and then it's got freedom units too. So yeah, pretty cool. You get your sponge and this, so no problem there. Let's, heating? Yes, we're heating. We'll let that go for a minute and give it a good chance to warm up before we start trying it. All right, first go with my solder. I'm not even going to bother with theirs. I'm going to just use what I know works. You get a roll with it, that's nice and all well and good, but doesn't mean we have to use it. So cool, that works. Let's check this oversight right now. Let's see what happens. If this is just sitting in there at full temp, let's see, let's get you off your cradle here. I actually don't see that even making a mark. Huh. Well, what do you know about that? So this, that plastic, it marks. That melts. But down in there, strange. It's leaving a vapor mark and it melted here, but it's not melting down there. So maybe everything's fine. Interesting. I didn't expect that. Is that metal down in there? I gotta check that. So it does appear that that's a metal cover back there. It's non-ferrous though, because the magnet doesn't stick to it. So that's cool. So oversight was indeed thought of. That's kind of nice. Let's go ahead. So we should be, according to the iron, we are at 450 degrees. Let's see what this here device has to say. This is my new, just a thermocouple, just a standalone thermocouple for soldering iron use, and well, other things too. I bought it just, well, because it's under 20 bucks. I've already shot the review on it, so I bought it because it's so much easier than messing around trying to hold an iron on a moving thermocouple. This just made sense to me to just grab one that's ready to go and nice and stable for the bench. So looks like we are in the neighborhood of 200 Celsius thereabouts, according to that, which is nowhere near the 450 that we're set to. We're creeping up, but let's see. It could be because we don't have enough load on it. That should have given it a little wake-up call. See if it starts. Yeah, it's shooting up now. So there we go. We peak out no problem. So it was just in some kind of an idle. So 440. Geez, that's off like 441. And we're set to 450. Man, oh man, that's close. For me, this part is kind of irrelevant. For most hobbyists, to be honest, this isn't as critical as what you'd think. For me, it's not critical at all. I could really care less. As long as I get to the temperature, I run my irons wide open and control the exposure with my contact length on the part. But the problem with running wide open is the heat transfer into the handle here, and that's going to be our next test. I can solder all day long here. Honestly, the only way to know how good this is going to be over time is to use it. And right now, I'm liking the way the handle feels a lot. It's really, it's got the comfort grip and the same tips I'm used to. This is old school everything, and I guess, well, we can hit it with, like, I could drag pools of solder around all day long, but let's hit this. This is a massive prong for 110 volt going through a huge ground plane here by the looks of it. Lots of copper there, and we're fully molten there now. It has no problem. It didn't even flinch. That is fully molten. So yeah, that's absolutely fine. If it can heat up something, let's try another one. Let's see if we can get you a better angle. Make sure you can see what I can see. There we go. That should do. Let's try one of these large ones here and just see, do they get molten? And could we work with this? Like I say, the only way to know is to just get it into use. And it's struggling with that, but any iron is going to. That is a big, huge inductor through a huge amount of copper on this board, and we're there now. We're fully molten. It's no problem. That is a removable component. Yeah, we could work with that. If I just held it there and gave it some time, I think yeah, it's fine. That's fully there. So that's all right. And then obviously we can play around. We could solder components, but I think anyone who's watching this video knows that pretty much any iron is going to be able to do any of this. It's no problem. We just need to put it into use and just get it being used. It's absolutely fine. I'm good with that. So let's let this get hot. and just see what happens. I think we'll get the thermal camera out and just see, and I'll show you a problem that an iron can have. This is pretty cool. I just changed the temperature set point, and what it does is it shows you your set point on the screen for a short time, and then goes back to what the actual is, and you can watch the actual falling back down. We just came down from the maxed out reading, but if we go back to max, it probably should flip over, and yeah, we can see it trend up and follow to our actual. So I kind of like that display. I think it's pretty standard now, but my old WEP, it doesn't do that. At least not when you're changing it. It seems to not show until it's kind of too late, until you're already tracked to your set temperature. So let's just try a set point of 300-ish and see whether we hit that. One more test of kind of the mid-range. 300 is a little bit on the low side for some soldering, but I guess some people might solder at that if you're dealing with really sensitive stuff. So that says we're there. So let's go ahead and see if we are. I thought it was maybe still tracking down a little bit. I think it kind of is, but 335 and still dropping. So I think it just needs some time to dissipate. Let's give it another minute. Okay, I gave it a second, cleaned the tip, and hit it with some fresh solder. Just tinned the tip. Let's see where we hit. That's looking a lot closer. Wow, that is, and I by no means know if this thermocouple is super well calibrated. I haven't checked it that close. I checked it real quick just with my own thermocouple, and it seemed to be bang on. But yeah, that's plus minus 1 to 2 degrees. That's cool. So, okay, well, it agrees. So we can say probably okay if you wanted something right to the temperature and wanted to be kind of guaranteed that your set point was good. Well, I think you're probably okay with this station. Well, let's find out. Is the cord capable of handling a touch? No, it is not. It burns and it melts. So, little fail there. It is not high temp to the iron, and that might come back to bite this thing. Well, I'll tell you right now too, my WEP ones are not, but they melt too, so it is what it is. But these are at least changeable, as we'll touch on in a minute. So okay, maxed out. Here's our weakness on this type of an iron. On my old WEP here, this area gets screaming hot if I leave this idle and at temperature. The heat soak through the iron is to the point of being uncomfortable on this, and I've seen that on many irons. So I think that's a more valid test than dragging solder around a board. Does the heat creep up into the handle and make it difficult to work with? So we just give this some time, maxed out, and let's take a look. Enter our FLIR i7 thermal imaging camera. This is my good old FLIR. This is a wonderful camera that I've had for many years now. Was really expensive when I got it. Bought it used, but this does the trick for doing tests like this. And this is what we want. I want to know, is that handle, how hot is it? Now, the reason I want to do it with this camera is because me saying ouch or that's warm, well, that doesn't come across on video too well. Whereas this, well, it's empirical. This is actual evidence. So let's lock this in and do an actual temperature reading. Okay, I locked this in on a spot measurement. The camera is fully up and calibrated and running. Up at the end here, you can't, that's not accurate because it's on shiny metal, the emissivity of we're getting reflected apparent temperature and all kinds of craziness. But up here, this black area is totally trustworthy. Well, it's got a little bit of gloss to it, as you can see, but not much. That's plenty enough that we can get a pretty good measurement. But back here, this is totally believable. This is the emissivity of it is going to be not a problem. It's not going to alter the temperature reading. So we're at 44 Celsius. That's totally bearable. But that's not even the handle. Let's go. Right here is our handle area at 33C. That is completely fine, and I don't feel any difference. That's my hands, and that's the temperature of my hands. So this is absolutely fine. There is no heat creep. This is maxed out right now. We're at full tilt boogie. So no issues with heat creep up the handle at all, and it's been quite a while. I gave it some time, so I don't foresee us having an issue here. Like tiny bit of warmth there, as you saw in the infrared, but nothing past about here. So that's going to be totally usable. I think it will get warm, but I don't think it'll be a problem. That's pretty cool. I'm good with that. If you guys are good with that, what do you think? Think that's a good test? I think that's a better test than dragging solder around the board all day long. I want to know, can I use this thing? I know it's going to melt solder. Now we know it'll melt big things, but I think I'm going to put this into service and just give it a go. I'm pretty happy with that. Let's take it apart. Okay, well, we have to take this apart because I mentioned earlier in the review that we have no capability of changing our iron itself out. And what I'm kind of sad to find is that the screws are underneath these feet, so you've got to be slightly destructive to get in there, which is, well, it is what it is. I would have really rathered have an iron that you could change without having to take it apart, but let's pop it apart. Okay, we're in, and I'm quite happily surprised of what we found in here. 2 screws for strain relief, and off comes our iron. 2 separate connections. Guessing that'll be sense and then heat. Nothing to it. This is a pretty simple little board setup. Really quite really simple. There's not much to it in there. There's our metal base for underneath our iron, and then you can actually see is it bent? Yeah, you can see the curve just barely there where it curves up and around the backside where I was testing to see if it would melt. So that's how they've done it. Actually, I'll pop that out. Just 2 screws holding it. And it actually must be stainless because it was non-ferrous. So looks like they didn't skimp and used nice stainless steel. So that's why our backside wouldn't melt, and no problem there. I do see another problem though. Didn't anticipate that. I didn't anticipate this at all. This kind of looks like a big oversight. Our cleaning wipe, it just fell down inside because that's where it goes. It's open to the bottom. Edit. I thought that all the solder and goop from the solder sponge, from the brass sponge, could go down into the bottom. They cannot. This brushed stainless shield actually seals it up completely here, that it can't get down and out of there at all. And there's actually a metal, another stainless button here for so your iron hits it when you're cleaning your tip here. When you stuff the tip through the brass, it butts up against more metal, so no plastic to melt. It looks like they did indeed think of things. This is pretty cool. This seems like it is sealed very well and that the solder won't make it down through. It'll be a little tricky to clean it out of there, but I guess you could just take your vacuum cleaner and suck it out, or just shake it around upside down and you'll get it out of there. But yeah, all is well. Make sure you check out PCBWay.com for their 4th annual PCB design contest. You can win real money and real prizes here just by submitting your design for the contest. You can see all the rules, information, and prizes at PCBWay.com. Other than that, pretty simple on-off switch, just typical spade connection. Our ground going through from there. This is grounded to here, and then it's also grounded. Is it grounded to our mains? Yes, our mains coming in is direct ground right there, the ground line, and then our hot and our neutral. So nothing to it. Pretty simple setup. Looks fine. I'm fine with everything. Good ground to there. So the idea being, you want to touch here to discharge yourself or anything. This is mains reference to ground. Unless you run this through an isolation transformer or something, you'll be fine. So it goes to ground, touch it, or you could probably clip. Yeah, you could clip. There's a lip here. You could clip on your anti-static wrist strap and clip right to this, and then it's right to mains ground. So that would work right to earth. So that's cool, kind of cool too. There's actually quite a good lip here. So you could use that to clip your wrist strap on if you're the type that uses those. But here is the damage to the iron cord sheath. It is not high temp and it does melt. So no problem to change. I'm good. What do you guys think? Is it a buy? I kind of like it. It's simple, not much to it. The price is reasonable, and what they're touting at, I believe it's 90 watts. Put the specs down below. That seems like a good little unit. I kind of like it. It's nice and light, nice and simple, and yeah, it kind of looks kind of cool too. So not going to replace my WEP just yet because of the hot air rework, but we do have a unit to test next from the same company. And we will test a rework station and see how they did with that. So they did send this to me for free, full disclosure, to give it a try, and they were actually really good to deal with too, which some suppliers are not. So although that doesn't matter for you guys buying one of these, I think it's worth noting when a company is good to work with and seems reasonable and just overall is nice. I'm good with that. So right on, guys. Talk to you soon.